So I, I want to talk a little bit about zones and grids right now and the value of each. This is a field in Illinois that I worked with for a while with Ted Peck. Some of you that might know him from the Midwest. He started working with this field in 1961, and that was really pre-fertilizer days. But as soon as the university took over the operation of the field, they fertilized it very, very heavily for over 20 years, hundreds and hundreds and hundreds of pounds of potash on the field. And so at the end of the fertilization period, there was pretty much no variability at all. And anything natural, which is this is more the natural condition of the field, is totally masked by the application of fertilizer. From 1988 till about 1992, 1993, anyway, to the end of the study, the field was allowed to just remove the potash from the grain, and no additional potash was removed. When that happened, then some of the patterns, like this one here in the northeast, they started to reappear. These areas of lower K started to reappear in the central part of the field. So what happens when you stop fertilizing or fertilize at a lower level, the field, because of maybe increased crop removal in those areas, or maybe the ability of the soil to sequester or hold more tightly to certain nutrients in certain places, it tends to revert back to the patterns that were natural. And we see this in North Dakota. I saw it in Illinois. I think it's just common. These are the topography structure and the soil type structures that were going on the Mansfield. This is the original potash, and you can see it related to these higher elevations in the field, this ridge that ran through the field. The EM readings also picked those up. So this is one of the fields I had to walk across because it was too muddy to use the Verus. Antonio Mallarino in Iowa looked at grids versus zones at 8 different sites in Iowa. He compared a grid of about 3 to 4 acres in size with zone sampling in the same fields. He thought both of them were very good, but the grid tended to be better in phosphate. And I think the reason for that, and Antonio does too, is that Iowa fields have been fertilized with phosphate for 30, 40 years now, very high rates, and so anything natural has been masked by the applications of phosphate, both as manure and also as heavy rates of phosphate fertilizer. But the zone tended to be better for potassium, and it also was better for organic matter, which I think should be intuitive, I think. The zone used fewer samples, but it required additional knowledge about the field. And this is one thing never to forget, is always involve your farmer or somebody who really knows the field well before you make a final decision, because they have an idea, whether they know it or not, about the quote-unquote personality of the field. And so showing them the map can give you a pretty good idea of maybe if you've hit it right or maybe not. It could be a total surprise to them, but very, very often when you show a map to a farmer, they'll start shaking their head and say, yeah, that kind of looks like the field.